Hello everyone. In this video, I want to provide an introduction to working with files in Python. Specifically in this video, I'll show you how you can open a file for reading and read the contents of that file into an appropriate data structure in Python. In the next video, I'll show you how you can take a data structure in Python, such as a 2D list, and write its contents out in the appropriate format to a file. So I have VS Code open here to a current working directory called FileFun. And in FileFun, I'm going to create two files, main.py. This will be a Python script where we will write our code to open a file. And then I also need to create that file. So I'll call this file data.csv. And I want to emphasize that data.csv and main.py are at the same level, meaning no more nesting, in the same directory called FileFun. Okay, so just emphasizing that I didn't say put data.csv nested inside of another folder called like data/data.csv or something. They truly are at the same level in this FileFun directory. Keeping your code project set up this way will make opening this file work just like it's going to work on my machine. So once again, FileFun has two files, data.csv and main.py. There's no nesting of directories within the FileFun directory where these files are stored. Now, the extension .csv stands for comma separated value, and it's a common file format used to store what's called tabular data, or data structured into a table. You can think about a table like an Excel spreadsheet. So an Excel spreadsheet has rows that go down the y-axis and columns that go across the x-axis. A row number and a column number uniquely identify a cell which stores a value. So a CSV file can store data in that same spreadsheet or table format using what are called commas to separate values and then lines to separate rows. So that being said, let's start putting some content into our data.csv file. It'll be plain text. The first line of our file will represent what's called the header row. In the header row, this is where we can put the names of our columns separated from each other by commas. So let's use really generic column names just so that we can get started working with data.csv immediately. Let's do an ID column, column 1, and column 2. And note that I'm using a single comma to separate my three column names from each other. I don't have any spaces around the comma. So this is going to be our header row. It is a comma separated value line in our CSV file. Then I press enter, and starting on line 2, I can have one or more lines that represent rows of data in my table or in my spreadsheet. So let's say I have ID 001. Let's say column 1 will store floating point values, so maybe I'll have like 1.5. And then let's say column 2 stores strings, so maybe I'll have hello. I press enter. And now I can put in 3 more values that represent the second row of my table. Remember, the first row here is the header and doesn't represent data rows. So let's do ID 002. Let's say 2.3. And let's do bye. Let's do 2 more rows. 003, negative 5.4, 545, something. And then let's do another word like here. And then 004, let's do 0.089, and then there. So just making up kind of some mixed type columns here. So I've got an ID column, which is counting numbers, but encoded as 3 digits. And then I've got column 1, floating point, and then I've got column 2, string. So save your file. Make sure that if you're in VS Code, you don't have that kind of black circle over your X here because that shows that you got an unsaved file. So save it. And then our goal is to head over to main.py, take a little bit of notes about what we're supposed to get started doing, and then do it. We want to open up data.csv and make sure that we can store the contents of data.csv in the appropriate data structure, which, because this data is two-dimensional and has order to it, will be a 2D list. So at the very top of main.py here, I'm going to take a little bit of notes, not too many, just a few. So let's start with what a file is. A file stores data on your file system. Sometimes this is referred to as being stored on disk, even though your file systems are more than likely not actually stored on disk anymore. Typically, we have something like flash memory or we have solid state drives nowadays. But back in the day, there actually were disks and they would spin, and that's why people would say your files were stored on disk. Next, the three-step file processing template. This three-step file processing template is not specific to Python in any way. I mean, this could be the same three-step file processing template that you would use, say, if you wanted to edit your resume in Microsoft Word. So the first step, if you want to edit your resume in Microsoft Word, or if you want to open data.csv in Python, is to open the file. The second step is once you have it open in, say, Word or in Python, then you want to process the file. So if we're talking about your resume here, then processing the file would include editing the file, writing to it, reading from it. If we're talking about what we're trying to achieve right now in FileFun, then processing the file would be, say, reading contents from it. We'll do writing in the next video. And then number 3, once we're done with our resume, we usually close it. Same thing in Python. Once we're done with the file, we close it. So our goal here is to open data.csv for reading, read its contents into a list. It'll be a one-dimensional list first, where each element in the list will be a string corresponding to exactly one line in data.csv. And then the most challenging part of all would be to convert that 1D list into a 2D list so that it's truly being stored in a data structure like a table or like the tabular data that it represents. So let's get started. Let's have a function here called readTable. So readTable is going to accept a file name. File name is a string which represents a path to a file we want to open. So real quickly, an aside here. So file name, as I said, is a string. So a file name represents a path, and a path can be an absolute or a relative path. Either one of these will work so long as your path, regardless of whether it's absolute or relative, is a valid path. Real briefly, absolute paths, they start with what's called root, which is a single / on, say, Mac or Linux-like machines. And then I'll put a semicolon here, and they start with a drive, such as C:/ or your C drive if you're on Windows. So essentially, absolute paths uniquely identify a location on your file system. So when we call readTable, if you choose to pass in an absolute path, then that should uniquely identify where data.csv is on your file system. It's probably in a different spot than on my file system, so make sure that it's unique for yours. On the other hand, you can pass in a relative path. So relative paths don't start with root or with a drive. Instead, they are relative to a current working directory, which is longhand for the acronym CWD. So for example, right now in VS Code, if we look at my project explorer over here, the current working directory of VS Code is FileFun. So I can just specify the names of files or folders or subfolders inside of FileFun without having to put everything before FileFun, including starting all the way with root, because I'm on a Mac, or C drive if I was on Windows, because FileFun is the current working directory of VS Code from which I'm going to be running main.py. Now, if you're going to be running main.py from your terminal or your command prompt, then you can take a look at your prompt to see what is your current working directory. So I'll pull up my terminal here. So it shows me right here that FileFun is my current working directory, and I can type pwd and I'll see the entire unique absolute path for where file fun sits on my machine. Root users gsprint desktop file fun. That's the end of the aside on paths. So we've got file name. It is a parameter that will store a string. The string represents a path, whether it's an absolute path or a relative path. It doesn't matter as long as it's a valid path. And our goal is to follow the 3-step file processing template, starting with step 1, open the file. So there's a built-in function in Python called open. So we can call open passing in file name and what's called a file mode. So for us, the file mode will be R, which is for reading. Open is going to return an object reference. It's of type text.io wrapper, and we can store that reference in a variable. I'll call this variable inFile, which kind of helps you remember that this is a file I'm reading in from. Now I'm going to skip down ahead to step 3, which is close the file, because I try to make it a habit where every time I call open, I immediately pair it with a call to infile.close so I don't forget, because it's really easy to forget step 3. You'll almost never forget step 1 or 2 because your program won't work without step 1 or 2. At least it won't work the way you intend it to, but it's easy to forget step 3 because most of the time your program will still work the way you want it to work, but it's always good practice to close a file when you open it. And I'll just emphasize here that close is a method that doesn't return anything, whereas open is a built-in function that does return a text.io wrapper. All right, so now step 2. With step 2, we're trying to read in all of the contents from data.csv. Python makes this really easy to do. In fact, I can read the entirety of the file into a 1D list. I'll call this 1D list lines with simply infile.readLines. That's it. Let's print out lines and take a look. I'm going to call read table, and I'm going to pass in data.csv, which is a relative path name. And remember, this is going to work because of how I set up this file fun as the current working directory of VS Code. Let's run it. So just like that, that's it. We already have a 1D list where every single element in the list is a string corresponding to an entire line of data.csv. So we had 5 lines, so we should have 5 strings. 1, 2, 3, 4, 5. You'll notice a few things, though, about lines. First off, it's one-dimensional, even though data.csv represents 2-dimensional data. Secondly, at the end of the first 4 strings, there's a new line character. And this new line character truly comes from the fact that I pressed enter at the end of each one of these lines to advance the file cursor to the next line. So we've got a little bit of cleanup that we should do. Let's do it. So a little comment here. We want to clean up the new lines and restructure lines into a 2D list, aka a table. So let's walk through each line in lines. And let's overwrite line with line.strip. This is a really handy string method that will remove leading and trailing whitespace characters. In a previous video, I went over some handy string methods, and this was one of them. So check out that video for a more formal introduction to strip. Okay, now that we've got the new lines removed, what we want to do is we want to split the line on comma so that all the values that are surrounded by commas are their own strings in a list. There's also a handy string method that we can use here, which is called split. So what I'm going to do is I'm going to have a new variable called values, which will store the 1D list that will be returned from a call to line.split, where I will get a list of words in the string using sep as the delimiter string. So sep is a string I can pass in to be used as the delimiter, which means what delimits all of the values in one of these lines? Well, with a CSV file, it's simply a comma. So that's going to be my delimiter that I pass in. Now values is a 1D list. I'm going to print it out so I can take a look at it. Here we go. So far, so good. Looks like I've got 5 iterations of my for loop, 1 for each line. And each iteration of the for loop, I get a 1D list where every single value is stored as a single element in the list. So like 001 is now stored separately from 1.5, which is stored separately from hello. This is our first data row in the CSV file. Great. We're really close to being done with our read table function. Now what we need to do is restructure these values into a 2D list. And I'll call that 2D list table. So now I'm simply going to call table.append values. So table is an empty list, but each iteration of the for loop, I'm going to append a list to it, which will make table a nested list. Now I'm simply going to return table so that my calling code can have access to our table data. So let's take a look at it. Here it is. It looks nested. It's got 1, 2, 3, 4, 5 elements in it. Each one of those represents a row as a 1D list. We are almost done. There's 2 last things that I want to do. First, recall that the header row of a CSV file is of a slightly different format than the rest of the rows, because the header row stores the column names, whereas the rest of the rows store the column values. So what I'm going to do is I'm going to store my header separately. So I'm going to call table.pop0, and that's going to pop header out of table and store it in a variable. So let's do this. Let's now see that our header and our table, the data part of our table, are now stored separately. So here's the header, and now here's the table with all of its values. So the main reason I wanted to do this is because if you look really closely at our table rows that store data, all of our values are stored as strings. You can figure this out by looking really closely and reading character by character in our output here. So like 001 is surrounded by single quotes, 1.5 is surrounded by single quotes, hello is surrounded by single quotes. But 1.5, for example, this is a floating point number. If we want to do any arithmetic with column 1 later, then we're going to need to convert this string 1.5 to the float 1.5. In fact, we want to do this for all of column 1 because column 1 truly represents a numeric attribute. So let's try that as our last task of this video. So I'm going to attempt to convert column 1, and when I say column 1, I mean the attribute labeled column 1, but also we have 3 columns, ID column 1 and column 2. Column 1 is at index position 1 with zero-based list indexing to a numeric type. So let's write a function called convert to numeric, and convert to numeric is going to accept the table. It's also going to accept header, and it's going to accept a column name, which will represent which column in the table do we want to try to convert to numeric. So this will be column 1. Let's write this function. Having some spelling issues here. So the first thing I need to do is figure out what index column name corresponds to. There's a really handy list method called index, which will tell me this. So I'm going to assign to a variable called column index, header.index, and I'll pass into header.index column name. So this should return the integer 1. And now I'm going to walk through each row in the table, and I'm going to attempt to convert the value at row subcolumn index to a numeric type, specifically to the float type. Now, I'll write this, but then I'm going to come back and improve it so it's more robust. So what I'm going to do is I'm going to overwrite row subcolumn index to be a float representation of row subcolumn index. Recall that the first time I call this, every single row has values represented in strings. So row subcolumn index is a string right here. I'm going to attempt to convert it to a float. Hopefully that's successful. Notice how the documentation says convert a string or number to a floating point number, if possible, right? Like I can't convert the string hello to a floating point number. This would crash my code with a value error. So I'm going to attempt to do this. And let's see how it works. So if I run this, notice the subtle difference, which is 1.5, 2.3, negative 5.4545, and 0.89 do not have the single quotes around them. These are truly now stored as floats, which is good. This is what we want. If we wanted to say compute the average of column 1, we could walk through, just like we did here with line 37, we could walk through each row in the table. We could accumulate the values in, say, row subcolumn index. They would all add up using binary addition. And then we could take the average by dividing that sum by the total number of elements we added up, or the total number of rows in table. That would work. But I'm going to break this. I'm going to go over to data.csv, and I'm going to say, actually, there's going to be another row here, 005, and it's going to have a missing value. I'm not going to actually put in a value for column 1. Often when working with data, we have a lot of missing values. So this is not uncommon. Don't forget to save your file. And then we go back to main.py. I'm going to run this again. And even though I didn't change anything in my code, just by changing my input file, I get different output. My code crashes. It says line 38. Here's line 38, where we do the conversion. Value error, could not convert string to float, and then it's telling me what string could not be converted to a float, which you don't see anything because it was the empty string, right? The empty string couldn't be converted into a number. So let me show you how to write this code a little bit more robustly. There's something called a try except statement in Python where you try some risky code. So let's do it. I'm going to try row subcolumn index is assigned float of row subcolumn index. And that might fail. If it does fail, then I'll have an except clause, which will essentially catch the error, which is a value error. And then down here, I'm going to print out could not convert, and then row subcolumn index. So let's try this again. And now my code doesn't crash. And you'll notice that the very last row here does still have the empty string. So this is something I'll want to keep in mind when processing column 1. But perhaps I might want to handle missing values in a better way, such as completely remove this row, or maybe fill this missing value with, say, 0.0, or the average of the non-missing values in the column. There's a lot of data science topics there that we could chat about, and we probably will in a future video. But for now, this is a good start. When first working with files in Python, we were able to read in a table. We were able to make sure the data was stored in a 2D list so that it was stored in the same way it was represented on disk. And then we were able to see how we could clean up the data a little bit, right? Convert the appropriate values to a numeric type that should be stored as a numeric type. Stay tuned for the next video where we will go through how to write a table, for example, this particular table right here, to a file by opening a file for write mode. Thank you for watching, and subscribe to my channel for more updates on Python videos.